There is a robot arm behind glass at the Computer History Museum in Mountain View, California. It has 6 joints, a hydraulic heart, and a mini computer for a brain. A small placard next to it reads, Cincinnati Milling T3, circa 1974. Most visitors walk right past it. They should not. That arm was the first commercially viable industrial robot on Earth. Ford welded car bodies with it. Volvo bought fleets of them. The company that built it was the undisputed leader in industrial robotics on the planet. Then the Japanese showed up. Within a decade, Milling had sold the entire robotics division. Then they sold the machine tool division. Then the company that had armed the Allies in World War II, that had invented the ancestor of every CNC router and 3D printer on Earth, filed for bankruptcy. So how does the largest machine tool builder in the world lose everything it built? This is Trade Archive, and today we are telling the full story of the Cincinnati Milling Machine Company. If you are the kind of person who cares about the machines behind the machines, give this video a like and subscribe. Cincinnati, Ohio, 1874. A German immigrant machinist named Anton Müller ran a small custom shop on Vine Street. He repaired sewing machines, built cigar wrapping equipment, and did odd metalwork jobs for local manufacturers. When Anton died, his son George inherited the business. George was a machinist, not a businessman. He needed a partner who could actually build things, so he brought in Fred Holz, another German immigrant who had a gift for designing precision tools. Müller and Holz started making screws, taps, and dies, basic fasteners. To manufacture them, they needed a milling machine, and the ones on the market were either too expensive or too crude. So Holz built one himself. It was a clean, rigid, well-thought-out design. When local manufacturers visited the shop and saw Holz's milling machine, they did not care about the screws. They wanted to buy the machine. In 1884, the two men incorporated as the Cincinnati Screw and Tap Company, bringing in an outside investor named Jacob Bloom, who put up $2,000 and took the presidency. Holz's milling machine won an award at the 1884 Cincinnati Industrial Exposition. Orders trickled in. The business limped along, making money on screws and getting attention for machines. Then, in 1887, a 21-year-old bank clerk named Frederick A. Geier walked through the door. Geier had not come to buy anything. He had come to collect a debt owed to his late father's estate. But when Fred Holz showed him the milling machine, Geier saw something the machinists could not. He saw a business. He bought out Jacob Bloom's stake for $7,000 and immediately began reorganizing the company around a single idea. Stop making screws, start making milling machines. By early 1889, the screw and tap line had been sold off to a group of employees, and the company was reincorporated as the Cincinnati Milling Machine Company. George Müller sold his share in 1891 and retired. Holz eventually sold his stock to Geier in the early 1900s and stepped away. The machinist and the metalworker had built a beautiful machine. The bank clerk figured out how to turn it into an empire. Geier was relentless. He installed rigorous accounting systems, expanded the sales network into export markets, and pushed his engineers to innovate constantly. By 1910, roughly 35% of the company's revenue came from overseas. The early machines that built the mill's reputation were the No. 4 and No. 5 high-power millers, heavy-duty production machines that could take deeper cuts and hold tighter tolerances than anything else on the market. Holz's original design had eliminated the belt drives that plagued earlier milling machines, replacing them with an all-geared feed mechanism that did not slip under load. That engineering philosophy, build it heavier and more rigid than anyone thinks necessary, became the company's identity. Then Geier made a move that changed the trajectory of the company. In 1921, he acquired the Cincinnati Grinder Company and its patents for centerless grinding. Centerless grinding was a method of finishing cylindrical parts without mounting them between centers, which meant the parts could be fed through the machine continuously, one after another, at speeds no conventional grinder could match. It was perfect for high-volume production. Henry Ford saw it immediately. Ford was buying Cincinnati machines for his River Rouge plant, and he personally pushed Geier to develop centerless grinders over center-type machines, because the throughput was so much higher. Cincinnati centerless grinders became the standard for automotive component grinding across the industry. If you drove an American car in the 1930s, the pistons, valves, and bearing races inside the engine were almost certainly ground on a Cincinnati machine. The innovations kept compounding. The 1927 Hydromatic was the first milling machine with a hydraulic table drive, replacing the mechanical feed systems that every other builder was still using. It gave machinists smoother, more consistent cuts at higher speeds. 2 years later, the company introduced the dial-type miller, a production machine that could index multiple workpieces through a series of cutting stations in a single cycle. It became the industry-standard production miller of the 1930s, the machine that every high-volume manufacturer wanted on their floor. By 1926, Cincinnati Milling was the largest machine tool builder in the United States. By the end of the decade, they were the largest in the world. But Geier's ambition wasn't limited to machines. In 1907, he bought a massive tract of land in Oakley, a suburb east of downtown Cincinnati, and began building what he called the Factory Colony. It wasn't just a new plant, it was an entire industrial campus, eventually sprawling across more than 100 acres, with a shared central power plant, a communal foundry, and room for allied manufacturers like Cincinnati Bickford Tool and Cincinnati Planer. The main factory alone had more than 6 acres of floor space. Geier convinced his competitors to move in next door because sharing a foundry and a power plant cut everyone's overhead. And then Geier did something more calculated. He built a company town, not with houses and a general store, but with benefits, employee cafeterias, an on-site medical department with a full-time physician, set up by Geier's brother Otto, a Cincinnati doctor, in 1914. Subsidized insurance programs. These were amenities that almost no American factory offered in the 1910s. The official reason was productivity. A well-fed, healthy worker builds better machines. The unofficial reason was control. If your doctor, your insurance, and your daily meals all come from the company, you think very carefully before joining a union. Geier's brand of welfare capitalism made the workers dependent on the mill for everything beyond their wages. If you walked out, you didn't just lose your paycheck, you lost your safety net. According to the company's own records, mill workers were generally disinterested in forming unions or becoming involved in strikes during the labor wars of the early 1920s. That was by design. The same year Otto Geier set up the company health department, something else was happening on the factory floor. Hermann Schneider, an engineering professor at the University of Cincinnati, had won a razor-thin 5-4 vote from the University of Cincinnati Board of Trustees to try an experiment. He wanted to send engineering students to work in factories, alternating between the classroom and the shop floor. The trustees agreed to try it for 1 year and explicitly said they would not take the blame if it failed. Frederick A. Geier sat on the University of Cincinnati board. He became one of the program's key champions. According to one widely told story, Schneider did not even ask permission to place his first students at the mill. He arranged jobs for 2 of them through a friend inside the company and only confessed to Geier after the fact. Geier was furious until he checked the students' performance records and realized they were outperforming regular hires. That experiment became the cooperative education model that thousands of universities use today, and Cincinnati Milling became one of its longest-running employer partners. Frederick A. Geier died of a heart attack in 1934. A month later, his son Frederick V. Geier was elected president. He had grown up inside the mill, served as vice president through the 1920s boom, and watched his father survive the Depression by keeping employees on the payroll year-round at reduced hours rather than cutting them loose. It was the same Geier philosophy, just a different generation. Take care of the workers, and the workers will take care of the machines. One of his first projects was to establish a subsidiary in Great Britain, planting Cincinnati Milling's flag in Birmingham, and eventually expanding to a second factory in Cannock. By the late 1930s, Europe was rearming. Frederick V. Geier made a decision that was either visionary or reckless, depending on when you asked. He authorized a massive expansion of the Oakley plant before the United States was anywhere close to entering the war. He was betting that the demand for machine tools would explode, and that the companies with factory capacity already built would be the ones filling orders, while everyone else was still pouring foundations. It was the kind of bet that makes you a genius if it pays off, and a fool if it does not. Geier had watched his father make similar calculated wagers for 3 decades. He trusted the pattern. The bet paid off beyond anything Geier could have predicted. When Britain and France started placing frantic orders for machine tools to build fighter planes and bombers, Cincinnati Milling was one of the few companies in America that could actually deliver. In 1940, Britain alone bought $16.5 million worth of Cincinnati machines. After Pearl Harbor, the Oakley plant became one of the most important factories in the Allied war effort. Every Jeep, every Sherman tank, every M1 Garand rifle, every B-17 bomber required parts machined to precise tolerances. Those parts were made on machine tools, and Cincinnati built the best of them. In 1942 alone, the company produced 17,511 machine tools. That was 1 out of every 12 machine tools manufactured in the entire United States that year. Frederick V. Geier told the press the plant was producing a new machine tool every 17 minutes. The workforce swelled from roughly 3,000 before the war to a peak of 8,561. Thousands of women joined the factory floor, operating machines that had been fitted with hydraulic assists to accommodate operators with less upper body strength. The company's foundry was pouring 35,000 tons of castings a year, and another 27 outside foundries were running around the clock to keep up with demand. 150 subcontractors across the eastern United States were manufacturing components for Cincinnati machines. The workforce had become an industrial army. The engineering department did not just build standard mills and grinders. They designed a specialized milling machine for thinning the aluminum cooling fins on air-cooled aircraft engines, allowing warplanes to fly faster and higher. They built an automatic profiler for the cams that controlled bomber gun turret lockout mechanisms, preventing gunners from accidentally shooting off their own aircraft's tail. They developed a centerless grinder for B-29 engine fuel injection plungers that held tolerances of 7/millionths of an inch. Every major naval gun barrel in the United States fleet was machined on Cincinnati equipment. For this, the company received the Army and Navy E Award for Production Excellence, one of fewer than 4,300 plants out of more than 85,000 war production facilities to earn it. The war ended. The mill kept building. And in May 1945, the company introduced something that would change every machine shop in the world. It was called CIM Cool, a synthetic water-based cutting fluid. Before CM Cool, machinists used straight cutting oils that smoked, stank, and caught fire. Cincinnati's engineers had been studying cutting temperatures since at least 1938, and they had discovered something remarkable. Dropping the temperature at the cutting edge from 950 degrees Fahrenheit to 900 degrees Fahrenheit extended tool life from 19.5 minutes to 99 minutes, a 50-degree reduction, and the tool lasted 5 times longer. CIM-Cool was the product of that research, and it became an industry standard almost overnight. What came next was bigger and more controversial. In 1949, a Michigan inventor named John T. Parsons won an Air Force contract to develop a way to machine complex aircraft parts too intricate for human operators. Parsons subcontracted the development to the MIT Servomechanisms Laboratory in Cambridge, Massachusetts, led by Gordon S. Brown with J.W. Forrester. The MIT team bought a surplus Cincinnati Milling Hydrotel vertical mill and retrofitted it with electric motors on each axis, driven by instructions encoded on punched paper tape. In 1952, they demonstrated the world's first numerically controlled milling machine. The paper tape told the machine where to move. The machinist just watched. Parsons, who had originated the concept, was furious. MIT had effectively frozen him out of his own project. He later said he never dreamed an institution as reputable as MIT would deliberately take over his work. But the technology was real, and Cincinnati Milling recognized it immediately. By 1955, the company had its own Air Force contract to produce NC machine tools for manufacturing aircraft components. In 1958, Cincinnati engineer Richard Kegg filed a patent for motor-controlled positioning of machine tools, further advancing the technology. This was the direct ancestor of every CNC machine, every 3D printer, every laser cutter running on computer code today. But on the shop floor, the reaction was not celebration. It was dread. To understand why, you have to understand what being a machinist meant in the 1950s. These were not assembly line workers repeating a single motion all day. A skilled machinist read a blueprint, calculated the feeds and speeds in his head, selected the right cutting tool, set up the machine himself, and then ran the part. He made judgment calls in real time. If the cut sounded wrong, he adjusted. If the metal was harder than expected, he compensated. The pace of production was, to a meaningful degree, in his hands. He had night school knowledge of applied science, years of apprenticeship, and a physical intuition about metal that no engineer with a slide rule could replicate from an office. That knowledge was his leverage. It was the reason he could negotiate. It was the reason his employer could not simply replace him with anyone off the street. NC, that is numerical control, erased that leverage overnight. The thinking moved off the shop floor and into the programming office. A white-collar engineer who had never touched a lathe could now write a set of instructions on a punch card, feed it into the machine, and the machine would follow the code exactly. The machinist's new job was to load the workpiece, press the start button, and watch. If the code was wrong, the machine would faithfully cut scrap at high speed, and the machinist was expected to stand there and let it happen. Historian David F. Noble, in his 1984 book, Forces of Production, documented the quiet war that followed. Noble's central argument was explosive. He showed that the Air Force and corporate management had a choice between two automation paths. One was NC, which centralized control in the programming office. The other was a cheaper, simpler system called record playback, which let a skilled machinist make the first part by hand while the machine recorded his movements, then replayed them automatically for every subsequent part. Record playback kept the machinist's knowledge in the loop. NC deliberately removed it. Noble argued the military and industry chose NC not only for precision, but because it transferred power from the union hall to the engineering office. The machinists knew exactly what was happening. Some responded with quiet sabotage. They fed machines the wrong data, let cutting tools break, artificially slowed production, to prove that the automated systems were inferior to human hands. Others simply watched their programmed machines destroy expensive workpieces and said nothing. It was a bitter, invisible culture war fought behind the facade of American progress, and it played out on the floor of the same Oakley factory where those machinists' fathers had built the machines that won the war. Meanwhile, Cincinnati Milling kept diversifying. In 1968, sensing that plastics would eventually replace metal in many consumer and industrial applications, the company introduced its first plastics injection molding machine. The engineers who had spent decades mastering hydraulics, heavy castings, and precision control applied that knowledge to a completely different material. The plastics division grew fast. By 1970, the company was building plastics machinery, specialty chemicals, electronics, and silicon wafers alongside its machine tools. The name Cincinnati Milling Machine Company no longer described what they did. In May 1970, the stockholders approved a new name, Cincinnati Milling. The word was coined in-house, combining roots meaning highest precision. 3 years later, Richard Hahn and his team, including engineers Merton D. Corwin Jr. and Ronald L. Tarvin, unveiled the T3. It was a 6-axis, hydraulically actuated robotic arm controlled by Cincinnati Milling's own achromatic mini-computer system. It could handle a 100-pound payload. It could weld, drill, load machines, and transfer parts. Ford and Volvo bought them for spot welding. In 1975, the T3 became the first robot used in aerospace manufacturing, drilling holes in aircraft components. Richard Hahn filed the key patent U.S. Patent 3,920,972 in July 1974. A T3 sits in the Computer History Museum in Mountain View, California today. Another one is in the Powerhouse Museum in Sydney, a former training unit from the Ford Australia assembly plant. For a brief window in the late 1970s and early 1980s, Cincinnati Milling was the global leader in industrial robotics. They had the technology, the customers, and the brand. They also had a problem they could not see coming, or more accurately, one they refused to see. The mill had spent decades building massive, highly customized, expensive machine systems for aerospace and automotive giants. A single Cincinnati Milling machining center could cost hundreds of thousands of dollars and take months to deliver. That was where the margins were. The lower end of the market, the small and medium job shops that bought simpler, cheaper machines, didn't interest Cincinnati's sales force. These shops made brackets, fixtures, custom one-off parts. They were the backbone of American manufacturing. But they weren't the kind of customers Milling's executives flew to visit. Japanese companies like Fanuc, Yamazaki Mazak, and Yaskawa did not make the same mistake. Backed by coordination from Japan's Ministry of International Trade and Industry, they built smaller, cheaper, highly reliable CNC machines and sold them directly to the American job shops that Milling had ignored. The machines arrived in crates, required minimal setup, and ran reliably for years. In 1965, American machine tool builders held 28% of the world market. By the early 1980s, that share was in freefall. One by one, the small shops that had once bought Cincinnati machines switched to Japanese equipment, not because they were unpatriotic, but because the Japanese machines were better, cheaper, and available now. Max Holland documented this collapse in his 1989 book, When the Machine Stopped. He chronicled the American machine tool industry's slow death through the lens of Hudal Industries, which owned a turret drill maker called Bergmaster. Hudal's president, Phil O'Reilly, filed a Section 301 petition in 1982 alleging that Japan's Machine Tool Builders Association had conspired with the Ministry of International Trade and Industry to rig the U.S. market through subsidized pricing and coordinated export strategies. The petition named specific companies and specific subsidies. The Reagan administration rejected it in April 1983, saying free trade was more important than protecting a declining domestic industry. The American machine tool builders were on their own. By the time Cincinnati Milling's executives realized the Japanese machines weren't cheap toys, but serious competitors, the damage was irreversible. Layoffs gutted Cincinnati's working class. Entire neighborhoods that had grown up around the Oakley plant lost their economic foundation. Milling's robotics division, burdened by high American labor costs and unable to compete on price against Fanuc and Yaskawa, was hemorrhaging money. In 1990, ABB Robotics, the U.S. subsidiary of the Swiss-Swedish industrial giant Asia Brown Boveri, acquired Cincinnati Milling's heavy robotics business. The division had contributed about $80 million in sales the prior year, and it was losing money. The company that had invented the first commercially viable industrial robot no longer made robots. Inside Millicron, the plastics division launched an initiative called Project Wolfpack. Each team was charged with improving machine quality while stripping out up to 40% of the cost and 40% of the components. It worked. By 1992, Millicron's plastics plants were recognized among America's best. The plastics side was profitable. The machine tool side was not. On August 21, 1998, Cincinnati Milling announced it was selling its entire machine tool division, the business that had defined the company for over a century, to Unova Inc., a Beverly Hills industrial technology firm. The price was approximately $178 million in cash. Milling recorded an after-tax loss of $35 million on the sale. To the executives, it was a strategic pivot. To the workers, it was a betrayal. Some of the machinists on the Oakley floor were third-generation employees. Their grandfathers had built machines for the First World War. Their fathers had machined gun barrels for the Second World War. They had grown up hearing stories about the mill the way other families tell stories about the family farm. And now the executives were selling it to a company in Beverly Hills that most of them had never heard of, pocketing their bonuses and walking away. The company dropped Cincinnati from its name and became simply Milling Inc., as if a century of identity could be shed with a paperwork change. Unova folded the legacy business into a subsidiary called Cincinnati Machine, merged it with Lam Technicon in 2002, and sold the combined entity to MAG Industrial Automation Systems in 2005. The machines that had armed the world in World War II were now 3 corporate transactions removed from the company that built them. Milling, now a pure plastics machinery company, was highly leveraged. When the 2008 financial crisis hit, automotive and housing construction, the 2 primary drivers of plastics demand, collapsed. On March 10, 2009, Milling filed for Chapter 11 bankruptcy protection in the U.S. Bankruptcy Court for the Southern District of Ohio. The filing terrified thousands of retirees who feared their pensions would vanish in the restructuring. The debtor-in-possession financing was led by Avenue Capital Group and DDJ Capital Management, who collectively held the majority of Milling's senior secured notes. They injected $80 million in new financing. The company emerged from bankruptcy as a private entity. In 2012, CCMP Capital Advisors acquired Milling and installed Tom Geier as chief executive officer. Geier expanded aggressively into India and China, modernized the plastics machinery portfolio, and built a high-margin aftermarket services business around spare parts and maintenance contracts. On June 30, 2015, Milling Holdings Corp. returned to the public markets, pricing its initial public offering at $20 a share on the New York Stock Exchange and raising approximately $273 million. 4 years later, on November 21, 2019, Hillenbrand Inc., an Indiana-based industrial conglomerate best known for Coperion process equipment and Batesville caskets, closed its acquisition of Milling for approximately $1.9 billion. Milling stockholders received $11.80 in cash, plus a fraction of a Hillenbrand share for each Milling share they held. The unbundling of the original company's legacy assets continued. On March 30, 2020, Hillenbrand sold the Simcool Fluid Division, the cutting fluid business born from those 1938 temperature experiments, to Du Bois Chemicals for $224 million in cash. And on March 31, 2025, Hillenbrand sold a 51% majority stake in Milling's injection molding and extrusion business to Bain Capital for $287 million. Meanwhile, the massive Oakley Factory complex sat empty. Decades of heavy manufacturing had soaked contaminants deep into the ground. Heavy metals, industrial solvents, residue from the cutting fluids that had once been the company's proudest chemical invention. The Oakley North redevelopment site, a 55-acre parcel bounded by Madison Road and the old factory streets, received a $3 million Clean Ohio Revitalization Fund grant, and an Ohio EPA Voluntary Action Program covenant in 2014. The foundry building, where 35,000 tons of wartime castings had once been poured, was demolished. In its place, a retail and residential complex called Oakley Station now sits on remediated soil, with department stores and apartment buildings where lathes and milling machines once ran 24 hours a day. A bronze medal sits in the Smithsonian American Art Museum in Washington. It is 3 inches in diameter, designed by the sculptor Joseph Renier in 1953. It is called the Frederick A. Geier Award. It honors the bank clerk who walked into a machine shop to collect a debt and built the largest machine tool company in the world. His machines armed the Allies, his engineers laid the foundation for the digital manufacturing age, and his factory colony pioneered a model of corporate welfare that kept unions out and workers loyal for half a century. The Millacron name still exists. It still makes plastics machinery. The injection molding machines rolling off the line in 2025 are descendants of the same hydraulic engineering tradition that Fred Holz started when he built a milling machine, because the ones on the market were not good enough. The Cincinnati Milling Machine Company is gone. The Oakley plant is gone. The machine tool division passed through so many corporate hands that its lineage is nearly untraceable. The T3 robot arm sits behind glass in a museum in California. The real question is not why Cincinnati Millicron declined. Every industrial company faces competition, disruption, and the pressure to adapt. The real question is what happens to a city, to a workforce, to an entire tradition of skilled labor when the company that defined all 3 of those things decides the future is somewhere else. If this story hit you the way it hit us, give it a like and subscribe if you haven't already. The next video is already on screen. We'll see you there.